Okay, we're going to start off today looking at even and odd functions. Now, most of you are familiar with even and odd numbers, but we also have even and odd functions. Here we have two examples of even functions. If I put a dotted line here over my y-axis, you can see that it cuts my graph in half so that each side is the mirror image of the other side. So this is considered an even function because if I flip it over that, you'll notice I end up getting the exact same thing. Same idea over here. It has to be symmetrical about the y-axis, and you'll notice the shape here. If I would reflect it over my y-axis, I would get this here. I would get the mirror image on each side. And you can see when I flip it, I end up getting the exact same thing. Now, that means if I have a point that's 2 units over and 4 units up, that would get reflected over here to 2 units to the left and 4 units up. So if I have a point 2, 4, I would get the opposite of that x, but I would get the same y value because they're at the same heights. When I look over here, for whatever x value I put in here, I need to have a corresponding point over here that's the opposite of that. But they need to have the same height, so they need to have the same y value. So in other words, when I put in a point x comma y, then I also need to have a point negative x comma y showing up in my graph. So in other words, if I would plug in a negative x into my function, I would need to get out the exact same thing as the original. And we'll talk more about that here in a little bit. Now we're going to talk about even functions. Even functions are symmetrical about the origin. So if I would take this point right here and rotate my graph 180 degrees about that point, I would get the exact same graph. And you'll notice I do get the exact same graph. Or same idea here. If I would take this, rotate it 180 degrees about my origin, I do get the exact same graph. So let's go ahead and talk more about that. If I have a point that's, say, 2 units over and 8 units up, if I rotate it 180 degrees, it would have to put me down here, which would be then 2 units left, and then still 8 units up and down, but I'm going down here, so it'd be 8 units down. So if I put in a point 2 comma 8, I have to have a corresponding point of negative 2 comma negative 8. Same idea here. If I have a point xy where I go so many units over and so many units up, I got to have this same corresponding point where I go that many units to the left and that many units down. So for an odd function, besides just being symmetrical about the origin, you could think of it as if I put in negative x, I need to get out the opposite of my original function. So if you're not looking at a graph and you're just looking at a equation or a function, how do you decide if it's even or odd? Well, in both cases, you put in a negative x, and then you simplify. If the simplified function is the same as your original, then it's even. If the simplified function is the exact opposite of the original, then it's odd. So how do we tell if this is even or odd? And by the way, most functions are not even, and most are not odd. Only a few are even, only a few are odd. Most end up being neither. But to check to see if it's even or odd, in either case, we need to put in a negative x. So we're going to go ahead and find f of negative x. So I got to put in a negative x here, and here, and here. Now I need to go ahead and simplify this. Here I have a negative to an odd power, which would still be negative, so I'm going to get a negative x to the fifth. Once again, here I have a negative to an odd power, so it's going to be negative, so it's going to change my sign in front because a negative times a negative is a positive. Here I have a negative times a positive, so it's a positive. By the way, if I had a negative raised to an even power, remember that a negative to an even power would always be positive, but I don't have that in this case. Notice what I have here in red is not the same as my original, so therefore it's not even. However, if I would just come along and change all my signs here you'll notice I would have the exact same thing as what I have here. So what I have here in red is the exact opposite of what I started out with. So therefore, it ends up being odd.